Hello guys, so welcome to this second part of my assembly notes series. So in this part, we are just going to get started with assembly. Basically, I'm going to show you how you can call assembly from your C++ code. It's not the only way, but it's the way I like it, and that's how we're gonna do it. And then in the next part, so part 3, we are going to get started and actually see how the Maya node works, what it does, and our first assembly code, right? I'm not going to write it from scratch because there is no point in you seeing making mistakes, typos. So we're going line by line the code, explaining what I did, why I did it, and what it does, right? So let's get started. Let's create a new project. This is going to be the dummy project, right? To just figure out how to run our assembly. So Win32 project should be fine. And actually it's also Win32 console application is fine, empty project is fine. So just call it awesome.test, awesome test, sorry. Next, let's do a console application, remove precompiled headers. Let's give it time. I think there we go. So even if we say don't want the freaking precompiled header, it's gonna put them anyway, so I'm gonna delete them. And now if I press Ctrl F5, we're good to go. We get our window up, our console up, and we can do our things. So how are we going to call assembly from C++? So first of all, the assembly file is going to be compiled separately, right, with a different compiler. So we're going to use the Microsoft Macro Assembler, not the regular C++ compiler. But the microassembler is going to generate an object file that we can link together, right? So at linking time, we will have the function that we can link it, but we also need to know the function at compile time, otherwise the C++ compiler doesn't know what to do. There is a way to do so, and basically we're going to say to the compiler, hey, there is going to be a function with this signature, you don't know what it is, you will know at compile time, so you don't worry about it, just know there is such function called with those arguments, and that's all you need to know, right? And that's called a forward declaration. How do you do a forward declaration? You just make the function declaration. You can even do class declaration, like class, like my class, right? That's a forward declaration. We're going to do a function which is going to be returning an integer and number from awesome, right? So that's a forward declaration, and we can use it, right? So that's perfectly legit C++ code. But if we try to compile and run, we're going to get an error, but it's not a compiling error, it's a linking error. Because of course, it doesn't find the symbol. We say, hey, you will have this function, but the linker doesn't have it. So it's basically calling us liars. So we need to provide the body of this function. But before getting ahead of ourselves, there is one thing we need to take care of. C++ mangles the name of the functions, right? Because it does that in order to support overloading. And we don't want to do that, right? Because assembly doesn't have overloading, right? It's bare bone. So the function signature, if you say has this name, that's what we're going to get. So in order for the linker to properly find the symbol, we need to say, hey, don't mangle this function name, otherwise you're not gonna find it, right? And you can do that with the extern C keyword, right? Basically, that's going to say, hey, this function is defined externally, so we'll find a link in time, and don't mangle the name, basically, right? So now we can compile, we still get the same error because we don't have the body. So let's go implement the body of the function. So we're going to create a new item, basically a new file. Let's call awesome.awesome, doesn't really matter. And we can write our code in here. The problem is that compiler is not going to use this. It has no idea what to do with .asm, right? So we need to explicitly tell, okay, please use this compiler. And we need to enable the Microsoft Macro Assembler. In order to do so, we're going on our solution, our project, sorry, then not properties, sorry. We're going under build dependencies, here we go, build customization, and we check and awesome, right? Here we go. So now compiler is available, and we're going onto the properties of our assembly file, and rather than have it not participating in the build, we're going to click on what we're going to use to compile, and that's the micro assembler. Good. Here we go. So now it's participating into the build. Of course, we're gonna get an error because our file is empty. So let's write the, it's not really a hello world, it's just returning a number. So we're going to declare a code segment, basically a segment where there is code. And you need to sandwich that between .code and end. Now we want to declare a function which has to have the same name of the one before we declare. Right, so number from asm, and you need to use the proc keyword, and then you need again to say that's the end of procedure. And p. And here you're going to write the code of your function. So here we're just going to move, I don't know, the value 30. You don't really need the semicolon. And then we're going to return. Return is really important, or you're going to get a flat out crash, right? And we're going to talk more what thread does, but that's basically it. That's our code, right? And moving the value 30 into the register RAX, it just basically is the return value of the function. Don't worry about all that. We're going to talk about register, return values, arguments, all this crap. That's just to show you how to run assembly code, compile it, link it together, having wonderful experience, right? So now we should be able to compile, no problem, and actually it doesn't like it because let's go 64-bit, right? Shall we? That's 64-bit assembly. So let's use it, and here we go, all good. So let's see if it runs. Didn't crash, so that's something. Let's just print out our number, right? Include on your stream. CL T and line. I always do this typo where the second column is a semicolon for some reason. So let's run it, and here we go. So let's add a pretty print. Asm says, right? Let's run it, and Asm says 30, and that's exactly the value we had here. Let's move this guy here, right? So we can change that to 100, right? And Asm says 100, right? So we're returning the correct value and we're printing the result, right? So that's the gist of it. That's how we're gonna run code. Now, usually what I like to do is to create a header file and put all our external C in there, right? So let's create a header, asm.h. There we go. Then I'm going to move the extern here, and then I'm going to include asm.h. My bad. There we go. And we get exactly the same result, right? So I find it just nicer rather than have the external declaration direct in the CPP file. And then we can easily include that wherever else we want. Then if you have multiple functions you want to declare, you can just declare them between curly braces. That's not the same thing, but we can have multiple functions declared like that, and we work just fine, right? So that's it for the second part. We will resume the third part, and we start to have a look at the actual node, right, in Maya. So that's it, guys. Have a nice one.